Now, one example I want to show you on that of machine learning. Okay, so machine learning is obviously a very important topic. So a lot of, AI stuff is done on machine learning. And these are some of the machine learning algorithms that you can learn about. So one is called logistic-regression, another is called multi-layer perceptron, then support vector machine, k-neighbor, nearest neighbors, k means clustering, hill climbing simulated annealing genetic algorithm, decision tree, and NMF. It's non-negative matrix factorization. Don't worry about how complicated it sounds. Just let's pick one thing like logistic regression or something. So in all of these examples, and I'll send you the link so you can go through these examples. So you have a bunch of inputs and a bunch of outputs corresponding to these inputs. So this is 1, 2, 3, like that. So this is the output, 1, 2, 3. So if it's the last one, the last output. So this is a snapshot, right, of all the things that happened. For this input, you gave this output. For this input, you gave this output, so forth. So you will create a model with this call. And then you will set up some training and say, go train yourself. After you train, this classifier model is now ready to predict. So then you're asking it, if I had this as the input, and this as the input, and this as the input, what is the result? Now what you have to notice is machine learning is already included in ZCubes. Okay, so that is this, what you're seeing here. So in ZCubes, all these libraries are under ZML. So if I took this code and I said I wanted to run it, I can remove the require because I don't need machine learning to be required anymore. It's already in ZCubes. So the only change I have to make it a ZML, and then change the console.log to just, don't have to just say output or something. Just make it an array and run it, and you have the answer here. So now, so if I made this live and I change that value, yeah, can't see any major differences here because it depends on the model. Let me show you it in this example. This is the next algorithm, because you have to understand these algorithms in detail. Let me show you the multi-level perceptron. So the idea basically is that the logistic regression you're seeing here is this piece. If I had a set of data points like this, and if I could draw one line through it, that is the regression line. If I have an X point, I can find the Y point. So my X here, that is my Y, right? So likewise, so that is how the first one works, the logistic regression. It is basically a regression with a lot more axes on it. The second one is called multi-layer perceptron. Multi-level perceptron is like, see, this is your neural network. This is a neuron in your brain. And this is the equivalent representation in the artificial world. Just like your neurons will take input signals through these dendrites, and then it'll give out a signal that goes to the next neuron and so forth. Likewise, an artificial neuron works the same way. So you have many inputs and they go into the outputs of the next neuron and so forth. So when you do this in multiple levels like this, that is called the multi-layer perceptron. The idea here is, and if you take this example here, that's the one I want to show you. So you have a lot of X inputs. These are the X inputs and these are the corresponding Y inputs. This is the next set of inputs, corresponding Y inputs, and so forth. So then you're making a multi-level perceptron model. And here, number of ins are 6 because you have 6 inputs coming here. Number of outs are 2. That is what it is showing. You could have more than 2. You can have 3 and all that stuff. Depends on your problem. But the way you have to look at it is, imagine you're driving a Tesla and this is the Tesla data. So it is saying that this is the visibility, and this is the amount of fuel in the car, or this is the friction of the road, or weather, and things like that. Those are the inputs. And then somebody jumps in front of you, or you didn't jump in front of you, or something like that. So this is the corresponding action of the driver, and was it successful? So that is how you have to look at each line like this. So given that is the input, you create a multi-layer perceptron like this. And you notice that 6 and 2 you understood, right? Is the length of these things. Then you have these different, multi-level, multi-layer values and stuff. But then you train the model with running it through so many epochs. Okay, so after you do this, now you have a model. And to that model, you can say, if I have these as the input, give me the predictions. So that's what is happening here. So let me take this much. Right? And then finally, I'm typing out MLP. So ZML is not defined. So you have to say ZML, capital ZML. That's all the only change you have to make. And then MLP is now defined as this object. Right? It's a model that the system has come out with. Now this is the representation of whatever data input output we gave, and that's what it is understood. Now we are asking it, given these, predict me the values. So now if you run it, you'll see it gave me these values. So that is the guess it is making. If I were to give, if let's say the car came across this scenario and this scenario and this scenario, the predictions would be what you're seeing here. So now let's see if I can make this into live and show you. See, when the value changes, these predictions also change according to that. Right? So this is the multi-layer Perceptron model. Likewise, they have so many different versions of machine learning here. So this is called support vector machine. Again, an XY set pair of things. And we call the model, train the model using different parameters. You can say max passes 10, 20, 30, whatever. And change these values, and they are all explained here, and different types of it, Gaussian, linear, polynomial, and all that stuff. Then you ask it to predict for a new value of SVM, tell me what the value is. So let's see if we can do this particular example in this version of ZCubes here. So the only change we have to do is remove the ML, we don't need that. Go to the ZML, ML and make it a ZML. And then you don't need console.log. So it's predicting the value is -1. So what it's saying is, given the situation, the original condition that inputs were these, it gave you -1. Inputs were these, so it is going to give 1, 2, 3, 4, 5, 6, 7, 8. It gave -1. The last one, this combination, it gave you this, right? So each X series is matching a Y series here. And then we are asking it to create the support vector machine for that combination of things. So you have basically created a model. And you can change this, say, 200 or 10 or whatever that you want to do. So it's going to change the model a little bit. And if you had something like, let's say, -1, we can keep changing it. At some point, it's going to give you some other, this prediction will change based on the data. So it's entirely based on the data. So if you made all of these into ones, if you removed all the things into ones, it'll probably give you one as the result. So that's kind of the idea. So each of these machine learning algorithms, like K nearest neighbor. So K nearest neighbor, it's an obvious way to think, right? You have all of these, and then you, let's see if I can show you the example, KNN. So if you take this kind of an example, it tries to make K nearest neighbor sets like this. And so if you give a new value, it figures out, okay, it's going to fall into this red area. So that is the value. That is the expected value. So typically you would use something like Python or something to do it, but we can do the same thing with ZCubes easily. So this is the K nearest neighbor module. K means clustering, that's another version of it. Hill climbing is another one. And simulated annealing is another one. Genetic algorithm is another one. So even if you take genetic algorithm, you can see how it works. So the only change you have to make it a ZML. And then you don't have to say console. You can say output. So these are the vector and the cost, basically. So that's all it takes to do machine learning algorithms inside of ZCubes. Very quick and easy. So you can try out these things and try to understand more of machine learning, because it is there in the browser version as well as in the ZBlack version. So it runs everywhere.